Hi, so in this video, what I'm going to talk about is lifecycle planning. So every software development effort goes through a life cycle, which consists of all the activities between the time that version 1.0 of a system begins life as a gleam in someone's eye and the time that that version evolves into 6.7.4.b and it takes its final last breath on the customer's machine. A lifecycle model is a prescriptive model of what should happen between that first glimmer and that last breath. For our purposes, the main function of a lifecycle model is to establish the order in which a project specifies, it prototypes, designs, implements, reviews, tests, and performs any other activities. It establishes the criteria that you use to determine whether to proceed from one task to the next. Many lifecycle models are available. In subsequent videos, I'll talk about different life cycles that do exist. But for here now, I want to talk about two very simple ones, which is called code and fix and commercial off the shelf. Code and fix is a model that is seldom useful, but is nonetheless very common. If you haven't explicitly chosen one of the other established lifecycle models, you're probably using code and fix by default. It's probably the default model you're using. If you haven't done much project planning, you're undoubtedly using code and fix. Combined with a short schedule, code and fix gives rise to a code like hell approach. When you use the code and fix model, you start with a general idea of what you want to build. You might have a formal spec, or you might not. You then use whatever combination of informal design, code, debug, and test methodology suits you until you have a product that's ready for release. This model has two advantages. First, it has no overhead. You don't spend any time in planning, no documentation, no QA, no worrying about how to enforce standards, or any activities other than just pure coding. Since you jump right into coding, you also show signs of progress immediately. The second big advantage is that it requires very little expertise. So anyone who's ever written a computer program and is pretty much familiar with the code and fix model. Anybody can really use it. For tiny projects that you intend to throw away shortly after they're built, this model can be useful for small proof of concept programs, for short-lived demos, or even throwaway prototypes. For any kind of project other than a tiny project, this model is very dangerous. It might have no overhead, but it also provides no means of assessing progress. You just code until you're done. It provides no means of assessing quality or identifying risks. If you discover, say, 3/4 of the way through coding that your whole design approach is fundamentally flawed, you have no choice but to throw out your work and start over. Other models would set you up to detect such a fundamental mistake earlier when it would have been less costly to fix. In the end, this lifecycle model has no place on an actual rapid development project, except for small supporting roles that we're just talking about. The next thing you want to consider when choosing to make software is whether or not you want to buy software off the shelf instead. Off-the-shelf software will rarely satisfy all your needs, but consider the following. Off-the-shelf software is available immediately, right? In the intervening time between when you can buy off-the-shelf software and when you could release software of your own creation, your users would be provided with at least some kind of valuable capability. They can learn to work around the product's limitations by the time you could have provided them with some custom software. As time goes by, the commercial software might be revised to suit your needs even more closely. Custom software probably won't turn out to match your mental vision of the ideal. Comparisons between custom-built software and off-the-shelf software tend to compare the actual off-the-shelf software to the idealized custom-built software. However, when you build your own software, you have to make design, cost, and schedule concessions, and the actual custom-built product will actually fall short of that ideal you envision. If you were to deliver only 75% of the ideal product, how would that compare to the off-the-shelf software? So that's the things you want to think about before you start jumping into planning your own software project. So in the next video, what we're going to talk about is the granddaddy of them all, which is the waterfall model, which will give rise to a lot more useful cycles later on. Okay, thanks for watching this video. Bye.